2. Velocity. Whilst speed is a scalar, velocity is a vector. Velocity has both magnitude and direction. A velocity of 10 meters per second due east means it is traveling at a speed of 10 meters per second, heading east. The SI unit of velocity is still meter per second. A. Average velocity. Velocity results in change in displacement. The object moves from one point to another, and the velocity is then the rate of change of its displacement. The magnitude of average velocity is usually different from that of the average speed, since we calculate the average velocity from the change in displacement, while we calculate the average speed from the distance traveled. The roller coaster example shown below illustrates the idea. In this case, the average velocity from x to A, to B, to C, or to Y have different directions as shown by the red arrows. Example 6 is another situation to show that the average velocity and average speed are not necessarily the same in magnitude. B. Instantaneous velocity. The velocity at any specific time is the instantaneous velocity at a particular incident. The average velocity within a very short time interval is close to the instantaneous velocity at the middle of that time interval. Also note that the instantaneous speed and instantaneous velocity are always the same in size, and that an object moving at constant speed, such as the one in circular path, may have a varying velocity as the direction of the motion is always changing, while its speed is constant. And lastly, an object moving at constant speed is moving at constant speed in a fixed direction, and the motion is called a uniform motion, and the average speed is then the same as the constant speed, and also the same as the magnitude of the constant velocity. And so, the three are all the same in size. Three. Acceleration. In physics, acceleration may mean speeding up, slowing down, or even changing direction. More accurately, acceleration is the rate of change of velocity. So, acceleration is the change in velocity divided by the time taken. The unit, meter per second square. Note that the change in velocity can be due to the change in magnitude of velocity, or the change in direction of velocity only, as in circular motion. The unit of acceleration looks strange, meter per second square. So what does that mean? For example, an acceleration of positive meter per second square means the velocity increases by 2 meters per second. On the other hand, a deceleration of 3 meters per second square means the velocity decreases by 3 meters per second. Example 7 on the next page shows you how you may calculate the acceleration when the change in velocity in the time interval is given. Finish checkpoint 5, as well as multiple choice questions in practice exercise 1.3 before you come back to the next physics lesson. And make sure you have copied all the notes that were shown in the video. Thank you.